Question 23. In an inter-school mathematics contest, schools can register teams in junior and senior categories. Information on the number of students and participation fee per team in each category is given in the table below. So there is number of students per team, junior category 6, senior category 4, participation fee per team, junior category 2,000, senior category 3,000. The organizing committee projected to register X junior teams and Y senior teams. A. For the contest to take place, the following conditions must be satisfied. 1. At least 2 junior teams must be registered. 2. The number of senior teams must be more than half the number of junior teams. 3. The total number of participating students from the 2 categories must not exceed 48. 4. The total amount of money raised from the participation fees must be more than 12,000 Kenyan shillings. The question is, write down inequalities in X and Y that satisfy conditions for marks. So that is the whole question. This is another part, B. From these statements here, and whatever you've been given information in the table, you're required to form inequalities in X and Y. Remember, X represent the junior teams, X represent the junior teams, and Y the senior teams. So let's go to part 1. At least 2 junior teams must be registered. At least 2 junior teams must be registered, given that they are X junior teams. So at least 2 means that the junior teams, which is X, should be greater than or equal to 2. That is what we mean by at least 2. That is, so at least 2 means 2 or more teams must be registered. So X is greater than or equal to 2. Let's go to the second inequality. The second inequality, the number of senior teams must be more than half the number of junior teams. The number of senior teams, which is the senior teams, Y, represented by Y, must be more than half. Must be more than half. Must be more means greater than half the number of junior teams. Junior teams are X, so that would be half X. That is the inequality you form from that statement. The number of senior teams, which is Y, must be more. More means greater than half the number of junior teams. That is half number of junior teams, which is X. Third one. The total number of participating students from the 2 categories must not exceed 48. Must not exceed 48. So what do you mean by must not exceed? Must not exceed means should be less than or equal to 48. To get the number of students, remember the number of students per team, we have 6 for junior category. Those are the number of students. Then there are how many teams? For junior, there are X junior teams, and one team has must have 6 students. So if there are X teams and one team must have 6 students, then the total number of students for junior category should be 6 times X, which is 6X. What about for the senior? For the senior, there are Y teams. Number of students per team, one team should have 4 students. So what about Y teams? One team should have 4 students. What about Y teams? Should have how many students? It's Y times 4. That is 4Y. Should be 4Y. 6X plus 4Y. And this is the number that you're supposed must not exceed. So when you add the 2, a number of students for the junior and senior category must not exceed means less than or equal to 48. We can simplify these by dividing everything by 2. Divide everything by 2 like this. And this one will give 3x plus 2y less than or equal to 24. Then from the other statement, the total amount of money raised from the participation fees must be more than 12,000. Must be more than 12,000. So look at the fee from the table. So from the table here, we have the fee per team. One team for the junior should give 2,000. So what about X teams? X teams should give 2,000 times X. 2,000 times X. So that is the fee for the junior teams. One team should pay 2,000. So X teams, 2,000 times X. Plus, what about for the senior category? Senior category, we have 3,000 per team. They are Y teams. So the total amount of money is 3,000 Y. 3,000 Y. And this is the amount that you're told that it must be more than 12,000. More than means greater than 12,000. That we can divide everything by 1,000 to simplify this. Divide everything by 1,000 like that. These should give 2x plus 3y is greater than 12. And those are the inequalities that you can form from those four statements. The first one is there, the second, the third, and the fourth. Part B, represent the inequalities in A on the grid provided. So we have these inequalities that we formed. These are four inequalities. So these are the four inequalities that we formed. You're supposed to represent them on the graph. Now to draw these, we're going to begin with the first one. The first one is here, x is greater than 2. So which line are we going to draw there? The line you're going to draw is the line x is equals to 2. And that line should be continuous. Continuous in the sense that you can see there is equal, greater than, or equal. So all the points lying on that line are part of the solution. Any point that lies on that line will be part of the solution. Continuous line. Then we go to y is greater than a half x. So the line you're going to draw is y is equals to a half x. So to draw that line, you need at least 2 points. So I'm going to just prepare a simple table here. Just a simple table you can use. So any point, for example, when x is 0, y is 0. When x is 2, you can choose any point as long as you're using this equation to substitute these values. So when x is 2, substitute there in that equation, you get y will be 1. When x is 4, y will be 2. So these points are enough to draw that line. And this line, since this one is greater than, there's no equal sign there. So this line should be broken line. Then we have this 3x plus 2y is less than or equal to 24. So the line you're going to draw here is 3x plus 2y is equals to 24. So again here we can just prepare a table. We have 3 points, at least 3 points. 1, when x is 0, just substitute in this equation, y will be 12. When x is 4, let's say 4, y will be 6. We're using this equation to fill. Then lastly, when x is 2, this will be 18, 6. So this will be 6, 18, this will be 9. So we're going to use these points. Then the last one we have is on. So 2x plus 3y. The line you're going to draw is on this line, before I forget, less than or equal to. There is equal sign. So this should be a continuous line. Let's go to this. 2x plus 3y is greater than 12. So the equation the line that you're supposed to draw. 2x plus 3y is equals to 12. So again, create a table here. So again, when x is 0, y will be 4. When x is 4, this is 4, this will be 8. Let me see. When x is 4, you should be careful when you're choosing the values that you don't get decimals. Make it easier to draw. So this will be 8. 12 minus 8 will be 4. So that will not be efficient. So let me use 3 instead. When x is 3, you need at least just 2 points. That one is good for confirmation. So when x is 3, we have this is 6. This will be 2. I'll choose another one. I think those ones are enough. Those ones will help us to draw. Have 2 are still going to work to draw. So you have these tables that you're going to use. So I'm going to use this one to plot. So looking at these values, I don't see very big values, so I can use a scale. 1 centimeter represent 1. That will work. Both axes that will work very well. So the first one, so this one will be the x and the y. Now is given there already, so mark is just plot these. So we have the first one, this one, x is equals to 2 is this line. X is equals to 2 is this line that is here. X is equals to 2. So that is the line. X is equals to 2. And before I forget, I just drew a continuous line. That line should be continuous. So that this is x is equals to 2. That is the line I've drawn. X is equals to 2. Vertical line passing through 2. The other one is y is equals to half x. So I'm going to plot this point. So we have 0 0. 0 0 is there. Then the other one is 2 1. 2 1 is here. So 0 0 2 1 is there. And then 4 2 is 4 2. 4 2 there. So that line should be broken and not be continuous. Already drawn continuous line, so it should be a broken line. So I'm going to show it like that. So this one is a broken line. Is a broken line. Since we said that this is greater than, not, there's no equal sign. So just ensure, I don't know how I'm going to put it so that you can see it is broken. So the other one is want to plot this one. 3x plus 2y is equals to 24. So 0 12. 0 12. So 0 12 is here. So the point is there, up there, 0 12. Then we have 4 6. 4 6. 4 6 is here. And then we have 2 9. 2 9 is here. So these are the points. So 0 12 is there. 2 9 is there. 4 6 is there. So that line should be continuous. That should be continuous line. So it's good to write the equation of that line against it. So this is a 3x plus 2y. So 3x plus 2y is less than or equal to 24. Then this one is y is greater than half x. Then this one is x is greater than or equal to 2. One more line, 0, 4. So we're plotting this one, 2x plus 3y is equals to 12, 0, 4. 0, 4 is them. Then we have 3, 2. 3, 2. 3, 2 is here. So for that one, you're going to use those 2 points only. So 0, 4 and 3, 2. That line should be broken. Before I forget, should be broken. Be a broken line. And still this one, don't forget, this one is broken also. This line is also broken. This one is broken. So now we've drawn all the lines. The only thing that is remaining is now to shade the unwanted side. So we begin with the first one. X is greater than or equal to 2. The unwanted side, if x is greater, the greater side is to the right. So the side that is unwanted, which is the left side, is what we're going to shade. That is the unwanted side, because the other side to the right is the required side. For the second one, this one, y is greater than a half x. Y is greater than a half x. So this is the line. So we don't know whether to shade above that line or below. So what we do, so y is greater than or half x. We just pick a point below that line and test. Like I can pick 3 or 5, 0. Let me pick 5, 0. A point that is below that line, 5, 0. Then I can substitute when y is 0, then x is 5. X is 5. So half times 5, that is 2.5. So is that true? Is 0 greater than 2.5? No. So meaning that this side where I picked that point does not satisfy this inequality, and therefore it is the unwanted side. So this side is the unwanted because the point that I've picked has not satisfied the equality. Line y is greater than half. Now from there, the other line is this. 3x plus 2y is less than or equal to 24. So the same thing we're going to do here. So let me do it here. 3x plus 2y is less than or equal to 24. So I will test this side. So I'll pick a point that lies on this side of that line. So like 0, 0. 0, 0 is a good point to test with. So substitute here, you'll get 0 is less than or equal to 24. When you substitute 0, 0, that point I've picked it on this side of the line. And you can see 0 is less than. So that side is the required side. It satisfies the equation, and therefore that side is the required side. So the other side that is opposite, that is above that line, the side that I'm shading, is automatically the unwanted side. Since the point that I've picked, the other side of that line, that is 0, 0, has satisfied the inequality. So what you do, so we've shaded, and the only thing that you're remaining now with let me see, there's one line that is there's one line there. This is okay, there's this line that is here. So there's this line that is broken here, this one, 2x plus 3y, 2x plus 3y is greater than 12. So this line that is here, that is broken. So let me pick a point on this side of this line, 0, 0. Just do it here, 0, 0, and I test. So when I substitute here, I get 0 is greater than 12. So you can see 0 is not greater than 12. 0 is not greater than 12. So that side does not satisfy. This side where I've picked this point doesn't satisfy them, the inequality, and therefore it is the unwanted side. So again, I will have to shade on this line on this side, because the point that I've picked on that side has not satisfied the equality. We always shade the unwanted side. The unwanted side is that. So now after shading that, we can see we remain with an area that is unshaded. That is the feasible region or the required region. That is how we do it. Part C. The organizing committee expected to make a profit of 200 for every junior team and 500 for every senior team that participated. Determine the number of teams of each category that should be registered in order to maximize the profit. We need to find the number of teams, that is X for junior and Y for senior, that should be registered in order to maximize the profit. We get that from this required region. And the best approach, there are several methods of finding these. You can use the set square sliding method, and you can use inspection. When I look at this region, we are going to use the inspection method. The inspection method. And for the inspection method, we actually check the corner points. The corner points of the feasible or the required region. The corner points of the required region. So identify the corner points. And these are the corner points. Look at this point here. Look at this point. Look at this point. And look at this point. This corner point will not give the values of X and Y that will satisfy the inequalities, because it lies on the broken line. This one again lies on broken line, which is this line. This one lies on the broken line. So we remain with this point that is here, 2, 9. And that is the point that is not located on any broken line. So this point, the corner point, this is the only corner point that lies on the lines that are continuous, meaning the points that we pick on those lines satisfy the equality. So of all these corner points, we have 1, 2, 3, 4. These corner point, this one, and then this one. The only one that will give us the number of teams for junior and senior that will give the maximum profit is this. This one is not included. This one is not included by the fact that they all lie on broken lines. So we have 2, 9 as a solution. So the number of junior teams will be 2. So X is equals to 2. Those are 2 junior teams. So 2 junior teams. And Y, these are senior teams. They are 9. So that is how we solve that question.